Good day, viewers. My name is Meknis. So, welcome to another episode of Meknis Physics. In today's class, I want us to learn capacitance. But before we go into capacitance of a capacitor, I want us to understand the concept of electrostatics. What did I say? Electrostatics. Now, what is electrostatics? Before we go into the definition of electrostatics, I want to give us two dimensions of electrostatics. After the dimension, believe you me that you will understand the concept better. Now look up. This now, we have unlike charges here, and we have like charges. We call this repulsive force. Repulsive force, and we call this attractive force. We can equally call this force of repulsion. Force of repulsion, and call this force of attraction. This is plus minus plus minus plus minus. This is plus 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 plus, or minus 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 minus. That is positive positive, negative negative. But here, positive negative, positive negative. Now listen. It is the discovery of this electrostatics. In fact, before the discovery of electrostatics, I believe that electrostatics is natural. Without electrostatics, I don't think there would be electricity. I don't think there would be flow of electrons. You understand? Now let me use this simple analogy to enable you come to balance as it connects to this topic. You know, let me assume you are a handsome guy and you see a pretty dancer, a pretty girl. Naturally, I repeat, naturally, and both of you have come of age. Let me assume you're a single handsome guy, 25, so to say, and you meet a single pretty dancer, a girl, 21 or 19, let me say 21, 22. You know, naturally, if she's a person of value, naturally you get attracted to her. Like you will like her. That is what? Positive and negative. Now, in biology, there's no procreation, there's no reproduction if the male and female don't come together to have sex. There won't be what? Reproduction. Now, take this analogy back to physics. If there's no positive and there's no negative, there won't be flow of electron. Now, let me take you down to chemistry. If there's no positive if there's no positive element and there's no negative element, I don't think there will be salt. Do you get? And the concept of acid and base won't be a reality today. Do you understand the point now? It won't have been a reality today. So when you have sodium plus, chlorine minus, when they comes together, it becomes what? Sodium chloride. The same thing is applicable here in electrostatics. So there's a rule here that states that is the rule of electrostatics, states that like charges repel and unlike charges attract. You do understand the point now? So you can't tell me that you're a man and you're attracted to a man. No, something is wrong with you. It's not natural. Or you're a girl and you're attracted to a girl. It's not natural. No matter how you try to paint it, it's not natural. Because it does not obey the rule of what? Electrostatics. It is abnormal. For the fact it's not natural, it is what? Abnormal. It's not normal. Did you understand the point now? So Now, let's keep this pertinent to the topic under discussion. Electrostatics. Since we've realized that we have like charges and unlike charges, we also have um, induction, like charging a charge body, bringing a charge body to a neutral body. That is electrostatic induction. Did you understand? Now, don't forget that what I have for you in today's lesson is capacitance of a capacitor. But I can't just jump into capacitance of a capacitor without giving you the ground principle or the ground rule that connects to capacitance of a capacitor. Okay, still on that, we've known that charge Q is equals to CV, quantity of electricity. Uh, and quantity, this C stands for capacitor. Uh, am I confusing you? No. Now, this is what? Voltage, that is potential difference. But before we go into that, someone might ask you this question. Listen carefully. Someone might ask you, the instrument used to test charge is what? Gold leaf electroscope. Gold leaf electroscope. Again, I want to talk about lightning conductor. Gold leaf electroscope and lightning conductor. On the top of every tall building, you must find a tiny metal that has sharp edge pointing upward. So the essence of that is to protect the house or the building from lightning, from thundering. Now, there's a question under that. You may be asked, for instance, which metal is best for producing or manufacturing lightning conductor? The answer is what? Copper. The answer is what? Copper. Did you understand? So that lightning conductor has an induced charge. And whenever thunder tends to occur, then there's an ion. It has a surrounding ion, but I don't want to go into that because, like I told you before, our purpose today is capacitance of a what? Capacitor. So at this point, I want to get started. Now, I believe you've understood this. Now, okay, on that note, what is a capacitor? What is a what? Capacitor. Capacitor is any device that stores charge. Any device that stores charge is what? Capacitor. Good. Now, I forgot to tell you about electrophorus, but remember I told you today we are talking about what? Capacitor and its calculation. Now, later on, I'm going to bring questions to enable you understand the concept of electrostatics. With the questions, then I will explain more. So stay tuned and subscribe to this channel and give this video thumbs up. Thanks for watching. So now, like I said, capacitor is any device that is used to store what? Charge. We have types of capacitor. We have variable air capacitor. We have mica. We have pepper and all that. That is three. But what are we looking at today? What I want us to understand in this lesson is how to resolve or solve any question under capacitance of a capacitor. Now I want to take you into two arrangements of capacitance of a capacitor. There are two arrangements. One is parallel arrangement and the second is what? Serial arrangement. Now, parallel arrangement. In this parallel arrangement, the we have potential difference across the plate, the capacitors, the same potential difference across, but this different what? Charges. What do I mean? Look at this diagram now. You have something like this. You have something like this, something of this nature. We have Q1, Q2, Q3. You understand? We have Q1, Q2, Q3, and here we have V. Here we have V, and here we have V.